This is Josh from LegoWorks here, and I will be teaching you how to use your NXT light sensor with your EV3. When my team got the new EV3 software, we noticed that there was no light sensor block. Since we had 8 light sensors from NXT and only 1 color sensor from EV3, it only made sense to try to use the light sensors. What I'll be showing you today are 3 myblocks that will allow you to use your NXT light sensors on your EV3. A calibrate myblock, a variable set myblock, and a light sensor myblock. The calibrate myblock sets the raw values of black and white to a file access block for later use. Since file access blocks are persistent, the values will stay on your EV3 even after being rebooted. Before we get started, I'd like to recommend that anyone who hasn't used file access blocks before, please go to the EV3 help files and develop a basic understanding of how they work. It's easy to mess up if you don't understand it. Trust me, I've made plenty of mistakes. We start our calibrate myblock with a file access block named calibrate, the mode set to delete. This will delete any previous calibration. Next, we have a color sensor block set to the port you have your NXT light sensor plugged into. Set the mode to reflected light intensity. This will turn on the NXT light sensor. Continuing on, we have a display block with the text set black and a wait block set to wait for the middle button to be pressed. This is instructing you to place a light sensor over a black area and press the button when ready. Up next is a raw value block set to the port number you have your NXT light sensor plugged into. The value of the raw sensor block is written to a file access block named calibrate into a line 1. Now comes a sound block, which you can set to anything you want to let you know that the black value has been set. For testing purposes, we've included a display and wait block to allow you to see if the correct value has been captured. Once your program is working correctly, you can delete these blocks. We now repeat the highlighted string of blocks to set the value for white, changing the display text to set white. This will write the raw value of white to the second line of the calibrate file access block. At the end of the program, we have a file access block named calibrate with the mode set to close. Closing the file access block will reset the line counter back to 1. That's it for the calibrate myblock. Let's move on to the variable set myblock. The variable set myblock writes the calibration values in the file access block to variables. You will need to initialize the black and white variables after each calibration or after a reboot of the EV3. We start the program with file access blocks we created in the calibrate myblock. First, create 2 new variables named black and white, mode set to write numeric. Set the file access blocks to read numeric and connect them to the variables with a data wire, making sure the black variable is first. This writes the first line of the file access block to black and the second line of the file access block to white. Follow up with a file access block set to close. The last myblock is the light sensor myblock. This will read the raw values from the NXT light sensor and convert them into a number between 0 and 100. Insert a raw value block and set the port to whichever port you want as your default. We added an input when creating the myblock that lets us set the port number to whatever we need. The rest of the myblock is the equation that finds the offset and slope. Raw sensor value minus black times 100 divided by white minus black. The final value of your equation should be connected by a data wire to an output you create when making your myblock. To test your new myblocks, run the calibrate and variable set programs first, then use a simple loop to view the values you are receiving from the light sensor myblock. If everything goes well, you should be seeing values between 0 and 100. Good luck and happy programming!